We are a small group. So I'm Andre Bottaro. I'm working with Orange for many years in the Internet of Things domain. And here I speak also in the name of the Eclipse OM2M project, which I contribute to for at least 2 years. And today what I would like to show to you is how Eclipse OM2M now has many resources for the developers of applications or full end-to-end infrastructures for them to use them, to use that and access a oneM2M technology even without reading the thousands of pages of the oneM2M standards. So Eclipse OM2M has really made it simpler. So we are in the IoT domain, and in Orange we especially use oneM2M in prototypes and now coming in a product in the smart home domain. And in the smart home, what we see, it is the vision of a new world of services coming from the variety of devices that is growing today. So you have more and more devices connected in the home. And of course, the smart home is not an isolated domain. You have the connection to the connected thing that you wear on yourself, so the wellness and the health domain. You have also the kitchen that is connected to the food supply, where you want to follow the food, the freshness and so on. And of course, the car is a domain in itself, and it is connected to the home. It is considered as a part of the home in some way. Then you want to have your content from the home or other things coming from the home in your car. In the Internet of Things, if you use to this domain, you have the first need always for the infrastructure is to connect devices that are deployed on the field with applications of industrials. And the smart home is like the other IoT domain. You need this type of infrastructure. In the smart home, what is a little more maybe specific, it is that you have at least an internet gateway that could play the role of this gateway that is connected to devices. But in the smart home, you may have also other devices or gateways that are directly connected to the internet and to the internet, yeah, and cloud platforms. And in the cloud, you may have one operator of an infrastructure may have at least one cloud platform, and it may be connected to the platforms of other device providers or service providers. And to have an infrastructure and full of connected to a wide array of devices and to have this new world of services, the main technical challenge is to deliver these APIs that will on this infrastructure that will attract the device makers on the one hand and the service providers on the other hand, and to have an ecosystem that is sound and that plays with interoperable APIs between them. So why choosing standards in the Internet of Things? It is to look for this interoperability key solution. We in Orange, at least in our team, we believe in oneM2M and we believe in standards because we want to propose a universal approach, and this is really something that in the operator mind, and especially in Orange, like in other operator organization. We want to scale up, and to scale up in this ecosystem, one actor like Orange could not develop all the drivers to all the connected things or all the applications. So we want to participate to wide open source communities, and we want to go fast, not reinvent the wheel. So we want to rely on available specifications that are living, and that's why we have chosen for instance, oneM2M here, especially in the smart home. oneM2M is a cross-sector standard, so it is not only meant for the smart home, and it has already successful deployment, for instance, in the smart city. You could see that also in other areas. The specifications are really generic and applicable on every domain, and you may have one only platform or an infrastructure with oneM2M nodes that are connected to several environments, be it in the industry, the city, the transport system, and so on. oneM2M is organized like the 3GPPs. It is a partnership project. 3GPPs tackling the network layer of the Internet of Things today, and here oneM2M is specifying the service layer of the Internet of Things, and it is really the same partnership project organization. We have now with oneM2M open source implementations. I will focus on what offers Eclipse OM2M today, but of course Eclipse OM2M has also interoperability with the other communities. And now there are some commercial deployments. We have commercial deployments since 2014 in this community. Orange is not here for the moment, but we may have an announcement later. So what is really key in oneM2M is this interoperability, APIs that are making the interfaces between service providers and the infrastructure on the one hand, and between the infrastructure and the device providers on the other hand. This is the same type of APIs. I focus on these APIs because this is really the thing that are really simply readable, and that is usable when we want to interact with other players. The specifications are not only on these APIs. There are a lot of specifications about how you manage your devices, how you make the security of your communication. All the aspects of the Internet of Things are addressed in oneM2M specifications. But if I, at least myself, I retain one thing from oneM2M, it is that it offers APIs that are effective between service providers and the infrastructure, and between infrastructure and device providers. What are in these APIs? So a client of this API will, thanks to REST technologies, discover the home devices. They could also discover other entities. Users and applications could be also represented in the data representation of oneM2M nodes. Then the client could browse into the device descriptions of every connected device, and in these descriptions are described in also data models that are specified by oneM2M. Especially this has begun in the smart home with a template that is called Smart Device Template, and we have now more than 50 devices and more than 100 device functions that are specified in this universal template that proposes oneM2M. There may be other competing description templates, but this one has some success in the standardization, and this is growing beyond the smart home today. Then, of course, when you discover your devices, then you want to collect some data. For instance, get a temperature device, a temperature sensor. Then configure your devices, act on device functions. We will act on a light bulb at the end of this session, and be notified of device events. And of course, this is specified. If we focus on the smart device template, this is a simple model that we can expose simply here. So a device is a set of device functions that are called modules, implementing module classes. And a module class is a set of actions, so an action being, for instance, switching on or off a light, a set of data points, and also a set of events. So a data point is, for instance, temperature data on a temperature sensor. And an event could be a smoke detection alert or any value change on a device. Then if you go into a concrete representation, here I have a LifeX bulb in this lamp, and this is, you will see that it is described as a device with at least a binary switch module, because this is the only thing that is mandatory in oneM2M device. And here this is a little more sophisticated because it has a color module, a color saturation module, and a brightness module to play with, you know, a lot of colors and the brightness, the saturation. And thanks to these APIs and data models, if you have heterogeneous technologies for your devices, so Philips Hue lights, Osram lights, I name some models because they are very well known in the domain. You could, thanks to these APIs and data models, see those lights with the same vocabulary, the same representation, and then act on this with the same REST APIs on the same data points, actions, events. So what has brought Eclipse OM2M to the community? It is to have implemented all those specifications. I named just a few of them because there are more than 20 specifications that comprises more than thousands of pages. And thanks to OM2M, then you have a reference implementation of nodes that you can deploy either on a cloud platform or gateway, or both, or many of these. You have client application samples in several languages. You have proxy samples to make the bridge with real devices, like the things I showed on the last slide. And then you have also some client samples in several languages to put your own code in small devices. So if I get into the details, if you go on the Eclipse OM2M website, what you have is, you have this, at least this reference implementation of a oneM2M node that you can deploy on a cloud platform or a gateway. This is a little like in the previous presentation. You had something that was deployable on the same code can be deployed on the cloud platform and the gateway. Here you have the same code, but of course on a cloud platform you will probably deploy all the components that are provided by Eclipse OM2M, and on the gateway you may be a little more lighter in your deployment and just choose the ones that are needed for your configuration. So on the website you can download those binary things to be deployed, and you can make some tests on your PC. You can of course clone and build the Git repository and have this code and customize this code on your platform and gateway. Configure and start this code. You have a web interface just to play with simulated devices, simulated lights. You have REST APIs just to play with the essential APIs. And then if you want to add plugins, make your own bridges towards your devices, then you can add your plugin, and there are examples to do that. Here's a list of the device clients samples in various languages that have been tested with OM2M. Of course, there are also other oneM2M clients projects that you can find on the web, and we just have not tested yet the full interoperability with Eclipse OM2M, but this is just to be tested. OSIoT client in C++, made by a partner project. a Python client made by Andreas Kraft, a colleague in Deutsche Telekom, not a colleague, but yeah, so someone we know in the community. You have also clients for Arduino, for Node.js client. I put something here on the website axter.io, and those clients were used, were made for a hackathon that has been organized by Sensinov, a strong contributor to Eclipse OM2M. And then soon we will have a client that is made with Node-RED that has been already used in, to organize hackathons, and this will come publicly on Node-RED repository end of June. Then I talked about bridges with real devices. oneM2M calls that interworking proxy entities. And from Orange, with Sebastian, we have provided with a team bridges for Philips Hue, LifeX bulbs, Netatmo thermostat camera with a station, a real coffee machine and kettle, so you can pilot your coffee thanks to oneM2M APIs. And there is also a bridge for Notion devices. So this is something that is written also in the wiki of the Eclipse OM2M project, so you can find the references. All is on the Eclipse Git repository, and those devices are implementing the data models with a smart device template, as I have described the model in the previous slide. Just something interesting, Sensinov has delivered also open source a connection to IBM Watson IoT platform, so this is to be noted. There are also applications that are available, so also coming from Orange, we have provided an Android application with the source code. This is a user dashboard that shows the devices that are connected to a node, to an infrastructure, and the applications that are also already connected and known by the infrastructure. You have a simple home monitoring application that gathers all the devices that are connected with some values, the actual values, the present values, and then also a camera stream and a camera that we can pilot through the thing. Then you have, of course, other available samples. The INSA Toulouse, so the School of Toulouse, has provided something for that is useful for hackathons. So a map of simulating a city or a home, and then you can locate, thanks to the emulator and their infrastructure, some devices on these maps. You have also a small demo here on axter.io, and we have provided from Orange a tool that is you could connect to a oneM2M node or infrastructure, and that can view the SDT structure details of any device. So you see the devices, the modules inside it, the actions that are available, and so on. Recent hackathons have been organized. I've mentioned that. The main one was organized by Sensinov in Dallas. It was co-located with a oneM2M meeting. And thanks to code that was given for Arduino devices for Node.js clients, the participants have developed at least more than 5 product demos, and 5 of them are well described by the teams, the participants, on axter.io website. We have a smart parking application, air pollution application connected to machine learning techniques, and water sensors using mysensors.org open network project. Other hackathons have been organized in India and in France by INSA Toulouse. There are some content that shows the ambience and the results in a text, but I didn't find the resources, so they are not available today. Last but not least, INSA Toulouse has delivered MOOCs, so you have several videos with slides that you could see yourself or provide to interested colleagues. So there is a course about Internet of Things and the standards, a course about resource-oriented architecture with the application to oneM2M and with Eclipse OM2M, and there are technical exercises that are given, and a course about interoperability, how you bridge a technology with another one, especially in the Internet of Things. And we will have those videos, or maybe different videos in French related to oneM2M. So just before concluding, I would add as a bonus something that I think will simplify a little more the access to oneM2M technology, and I will show you the things. Do you use regularly REST APIs in your work? Not fully. And among you, do you know Swagger tools and Swagger technology? Of course. So we will see how that Orange has made available, at least for partners that we could invite, a live server that is oneM2M above a product that is live, so it is Orange Data Share. This is a real product with that is making partners glad for some deployments, and then we will, thanks to this server, we will have the access to a Swagger page and play with at least one device through this page and REST APIs then. So I show you just what is data share. If you go to datashare.orange.com, this is something that is available for anyone. You could ask at least for an account. This is moderated. I have a client account, so here you have a client account. I've connected a lot of devices. You can collect many brands, be it Fitbit, Schneider, Netmod, and so on. And today, what remains connected, it is this Eclipse OM2M bulb. And this is me that has named this bulb Eclipse OM2M, and this is this LifeX bulb into this lamp. Then you need an account on Orange Partner website. I hope this is this is working. I think this is working. Okay, not sure this has something. Okay, and then so on the it does. I don't know why developer.orange.com. This is responding. So you have so if you want to do the same, you need an account on the Orange developer website, and then you see that we will have APIs on different domains, and in the IoT domain you will find the data share platform and other platforms. So I've already signed. No, I have to sign in. Just to show how it works, you have to declare an application, and in your application you have to say, I want to use data share API. So you have to add an API that is called here, data share. And the main part of my demo is here. Then when you have your developer account, you go to this page that is called Data Share oneM2M APIs Beta. because the main APIs of data share are proprietary from Orange, but here we have an experiment with oneM2M standard APIs. So there is a text, of course, explaining what those APIs offers, and then those who know Swagger tools, we recognize the format, the format of a Swagger page here. So the first thing you want to see is how to discover the connected devices. Just here, I want to filter on labels. So then, I have to put this one thing, and then I want to see the devices. And then, thanks to Discovery API, we see that there are 3 lines, so 3 devices. I think that the other LifeX devices may be at our work, at my office, and the thing that is here is the second one. So I will take the resource name of the second one. This is of course very technical, and it has to be automated in applications in the reality. And then with this name, I will get all the properties of this device, thanks to the retrieve resource API. And then here, this is of course something technical. You see that here there is a list of the modules that are in this device. So we see a binary switch here. We see that there is an oneM2M module class color module here, color saturation here, there, and the last one will be the brightness. I just want to switch on the light, so I will use the resource identifier of this binary switch, and then go to the last API that is called, how it is called? It is called update resource with a resource ID. So I put the resource ID here. Of course, thanks to Swagger, we have put some examples of JSON message to put in the body of the message. So I take here what should be sent to the device to make it switched on. So I put true, and then I send the message, and it comes to the light. So if you have followed the thing, I've sent just a JSON message to a oneM2M server, and this oneM2M server is connected to LifeX platform on the web, and the LifeX platform on the web acts on this device. Okay, of course we can play with. I can switch off this light, and I can play also with the colors if I take the color module and so on. Okay, so that was just to make it a little more real. And just to conclude, so you see that thanks to Eclipse OM2M, we have many resources now available for any developer to develop their own infrastructure. Maybe the same developer or another partner to develop devices, and others to deploy applications. And all of that with oneM2M APIs and data models. Thank you very much for your attention. And if you have questions.